Earlier we saw OSPF in IPv6 environment. We need to do EIGRP, and if you're aware of ISIS, I can also show you in ISIS, BGP, once the lab comes. So as of now, we are not going to focus on the routing protocol. I'm taking you to the next topic of the migration techniques. One of the easiest and widely seen migration from 4 to 6 is dual stack, which you already know. Dual stack is running both IPv4 and IPv6 parallelly on every link and every router. That's what simply dual stack means. The router is now doing function of two routers, IPv4 router, IPv4 routing, IPv6 routing. See, you have a separate adjacency table, separate RIB table, control plane, separate data plane. Though the physical ports are same, you're going to have two separate control planes, one for IPv4 and another for IPv6. There is nothing new to learn here. If you know IPv4 OSPF and IPv6 OSPF, enable both. We call it as dual stack. There is no special commands or anything needed to do dual stack. One thing we need to remember always is you are running two separate OSPF process. As a result, the utilization of the resource is doubled. Earlier you had only IPv4. Now you have IPv6. So utilization of resources doubled. Performance will go down if the network devices and links are not upgraded. So when you plan for dual stack, upgrade your network because you're going to do two process in one router. Earlier it was only one OSPF, for example. Now you run two OSPF, two separate process, two separate database, link state database, two separate neighbor table, two separate routing table, two different Dijkstra's algorithm. So I just take OSPF as an example and explain, but it is much more than that. Everything is doubled here. MAC table is same, but the adjacencies are made using link local address. So neighbor discovery, the neighbor table of IPv6 is different. Safe table is separate for IPv4 and IPv6. Routing table is separate. Any question that you want to ask in dual stack, you can ask because there's nothing more to explain. If you know IPv4 and IPv6 configurations and routing protocol configurations and etc., then you are good to go with dual stack.
So yesterday I did some lab. The host is getting IP, like IPv6 address, but I'm unable to ping from the same device.
From the same device, how
So
you
like,
will ping?
I mean, it's mean that same switch where the host is connected. From that switch, I'm trying to ping the host.
Hmm.
In that network, there are five devices. But out of 5 devices, if you ping from any device, it is not pinging.
Can you show me now?
It is in the different.
Okay, tomorrow bring it.
Yeah, sure.
because I cannot assume things and give you an answer. I want to exactly see what is really going on there. So you bring it tomorrow.
Yeah, sure, sir.
Any other question? Fine. So today let us focus on another method of migration. Let us assume your company is migrated already. You have 2 or 3 sites, and your company is IPv6. I put blue color to say it is IPv6. Your company is completely turned into IPv6. You don't need dual stack actually. When do you need dual stack? Some of the services that you run in your office needs IPv4 because IPv6 service is not available for that. Sorry, IPv6 enabled service is not available. For example, you have an application running between your head office and branch office, and that application is not developed with IPv6. It was developed using IPv4. So you need IPv4 to run that application, which is very important for your business. The business application don't support IPv6. You purchased long back, and those days no one focused on IPv6. So it was developed for IPv4 environment. You need IPv4 communication for some application. For some other application, you have IPv6 support. So you will do IPv6 communication, also IPv4 communication. In that case, you need dual stack. Or some of your branch office are still in IPv4, some are moved to IPv6. Then you need dual stack. But when all your sites are IPv6, you don't need dual stack. So your sites are IPv6, but your service provider has not provided IPv6 support, assume. Your IPv6 provides only your ISP provides only IPv4 support. ISP provides only IPv4 support. But you got IPv6 in your environment. And you want head office, branch office 1, branch office 2 to have IPv6 communication over this IPv4. What shall we do? The middle one is not IPv6. But I want to route IPv6 packet over this IPv4. What should I do? I need to build a tunnel. I need to build a tunnel. I need to build a tunnel that will. The tunnel is built using IPv4. I'll draw IPv4 in brown. This is brown tunnel, IPv4 tunnel, inside which it is capable of routing IPv6. So encapsulation. we need to take the IPv4 traffic, IPv6 traffic, and encapsulate with the IPv4 ID. For example, if I'm going from 1111::1111 to 2222::2222, I need to go to 200.1.1.1 from 100.1.1.1, meaning my tunnel source is this, tunnel destination is this. The original packet has got source address 1111 and destination 2222. I need to encapsulate with 100.1.1.1, 200.1.1.1. As a result, when the packet is about to go out, the ISP will read only this header, or before exiting, the router will look into the destination 200 and route the packet to ISP. ISP will route the packet to this 200.1.1.1, and here the decapsulation happens. This is removed when it is received on the branch office 1, and branch office edge router will read this address and it will deliver the packet here. This encapsulation is what I call it as tunnel. This is one of the migration method I'm seeing in the real world. Widely seen as dual stack and easy, that is easy. And I'm also seeing this for time being till the ISP provides you the full-fledged IPv6 support. You can manage with this tunneling concepts and you will have normal routing. Though it is tunneled, you don't feel difference. Neighbor discovery, everything happens through the tunnel. And these tunnels are dynamically established. For example, if I am pinging from this 1111, I'll call this as alpha, and this is beta, and 3333:3333 as gamma. If I'm pinging from alpha to beta, the tunnel will be established like this between these two. The tunnel won't be there always up. Tunnel will get dynamically built depending on what IPv6 destination you ping. If you ping this destination, the tunnel destination address will become 200.1.1.1. If you are pinging alpha to gamma, the tunnel destination will be this one. Let's say this one is 111.1.1.1. If you are pinging gamma, automatically the tunnel will be between these two. If you are pinging beta, the tunnel will be with this. This tunnel won't be there. How is this possible? Based on what destination IPv6 destination you ping, based on what IPv6 destination you ping, the tunnel IPv4 destination is derived. I'm using the word derived. Yes. If you want to derive the IPv4 destination using the IPv6 destination, like Bala said yesterday, the IPv4 address should be embedded into IPv6. That's the secret. So when you ping IPv6, the router can see the IP address of the destination, IPv4 address of the destination in that IPv6. That becomes a hint for the IPv4 destination, using which the tunnel will be negotiated and tunnel will come up. We call this as 6-to-4 tunnel technique, 6-to-4 tunnel technique. This is what we are going to do as a lab today. We are going to embed IPv4 into IPv6 so that when you ping some IPv6, from the ping address, the IPv4 destination will be derived, using which the tunnel can be negotiated and the connectivity happens between the sites. Ask me a question. Let's finish the pending lab, then we'll get into the 6-to-4 tunnel. What do you all say? Or you want to see the tunneling concept? Which one you want? Whichever you like. You want the protocol to be completed or the tunnel? Please be free.
Yeah, let us go. Let us
Okay.
go with the protocol first.
Sure.
We will go for the
Thank you,
tunnels.
sir.
Sounds
Now
good
I'm going to
me as
remove
well.
this OSPF which we already run, and I'm going to make it as EIGRP. No need of OSPF, and we are going to have EIGRP between these two, so that we can also learn redistribution. Here to here, I'm going to have EIGRP. And this is going to be another protocol, maybe RIP. This we'll put inside EIGRP. So one side EIGRP, another side RIP. EIGRP.
Or else, sir, EIGRP and OSPF. Since already OSPF is there, we'll configure this side EIGRP.
Why can't you try
the
that?
distribution.
You try EIGRP and
Yeah,
OSPF
sure.
after the class. So you may use the same model
Yeah,
what I'm
sure.
doing for RIP to EIGRP, and you can try OSPF to EIGRP. Yeah. So this is going to be RIP.
Yeah, sure.
For RIP NG, next generation, which is called IPv6 RIP, you need to give a process ID. The process ID can be a number or it can be a name. It can be a name. You are special. That's the name I'm going to give for the process ID. Okay, so let's see how to do it. First thing, remove OSPF. It's not allowing me to do. Go and hide. Okay. To remove the routing protocol which we configured earlier, I will say no IPv6 unicast routing. That's all. This will remove all the routing protocol that which I configured. Now, if I type show IPv6 protocol, I should not see any protocol. And I put the command back, IPv6 unicast routing. Done. So there is no OSPF. If you want, you can check show IPv6 OSPF interface brief. There is no OSPF running. Show IPv6 OSPF, nothing. Okay, show IP interface brief. I want to check whether I have an IPv4 address so that EIGRP can use it as a router ID. Show IP interface brief. I do have, so I don't need to worry. Show IPv6 interface brief. I should have interfaces for IPv6. I do have. Okay. Next is I'll go to the next router. Remove. No SPF. So I'm going to start with RIP. For that, show IPv6 interface brief. I have IP address. Show IP interface brief. I do have an IP address on the physical interface. That doesn't matter. We need an address. That's all. IPv6 command. IPv6 router RIP. And we need to give a name. You are special. If you want to give router ID for RIP, that's not needed. And you see, there is no network command. You cannot use network command, but you have redistribute command. Okay, so you can change the administrator distance if you want to change the max path. By default it is 0. Sorry, 4 max path. You can change, you can cancel split horizon if you want. Timers you can change. So where should I go? I should go to the interface only. Interface range loopback 0, Ethernet 0/0. IPv6 RIP. You are special enable. This is the syntax. Enable is the keyword. You must type after the process ID. So you don't need to go to the router mode like this. You can straight away come to the interface and do this. If you want to do some special operations like redistribution or something like that, you may need to go there. Otherwise, not necessary. Now, RIP is running. Show IP protocol, IPv6 protocol. You can see that RIP is running on this two interface. Now redistribution. RIP process ID is USR. You are special. Now let's go to router 2. In router 2 also I can go straight to the interface. Ethernet 0/1 IPv6 RIP. Here I'm going to say another name. You are blessed. Enable. Now RIP is already running between these two routers. You see, like we used to do in OSPF under the interface, IPv4 and IPv6 OSPF. We can do under the interface in RIP ng. IPv6 RIP is easy, no? Now let's check. Show IPv6 route RIP. See, through RIP, I have learned this. From where it is coming from router 3. See, it uses the link local address to discover. It uses the link local address to discover. The next stop, you don't see the DAD address. So if you want, you can ping now. What is next? Now on R2, we also run EIGRP as I told you. For EIGRP, the router ID is must. So show IPv6, show IP interface brief. I want to see when, okay, there is no IPv4 address. So you must give an IPv6 address, IPv4 address as a router ID. IPv6 router EIGRP autonomous system number. So I'm going to show you two different ways of configuring EIGRP here. One is this one, classical way. On the other router, I'll do in a newer way. IPv6 router EIGRP 100 and give the router ID, EIGRP router ID. This need not to be an address on any interface, just a name. And then I need to say no shutdown, very important. Very, very, very important. Don't forget to say no shutdown under the router mode. I'm not under the interface mode, you see. Under the router mode also you need to say no shutdown. This is the syntax. This is how EIGRP IPv6 version of EIGRP gets enabled when you are following the classical method. For the newer method, you no need to do this. I'll show you that on the router one. Here I need to say no shutdown. Now EIGRP process is enabled. You want to see? I'll show you. Show IPv6 EIGRP interface. See, EIGRP is running, but no interface is allocated. Let's go and enable, put some interface. Interface range loopback 0, Ethernet 0/0. IPv6 EIGRP 100. That's all. There is no enable command, nothing needed. Now, if you say show IPv6 EIGRP interface, you can see two interfaces. So EIGRP is running here. Let's go and enable EIGRP on R1. On router 1, I'm going to use a newer method. I said newer method. For that, you don't need to start with IPv6. You see, in the earlier method, I was starting with the command IPv6 router. But in the newer method, I can say router EIGRP, give any name or number, that doesn't matter, any name or number. We are blessed. Now I'm going to say address family, IPv6, autonomous system number 100. This is newer method. Now I said this and I can see already neighborship is coming up. But did I go to any interface and configure EIGRP? No. Do show IPv6 EIGRP interface brief. Interface. It is saying I'm already running. Surprise. Did I enable? So the entire, I did not say no shutdown for the newer method. The entire router is running EIGRP. See, I did not go to any interface. Show run interface Ethernet 00. Do you see any EIGRP command under the Ethernet? But if you go to R2, you will find that. Show interface Ethernet 0/0. Show run. Here you see the EIGRP command. But in router 1, we did not say any EIGRP command. As soon as I said address family IPv6 blah blah, it started running. If you don't want to run, then you need to put passive interface command. All right. So that is how the newer method works. Newer is better because mostly people will have one protocol in the entire office on all interfaces. So instead of going to every interface and say, you run EIGRP, you run EIGRP, you run EIGRP, instead of saying that, you can say which interface should not run EIGRP by doing passive interface. Topology base command is topology base passive I'll check that later and tell you the passive interface command. So this is the difference. The classical method, you need to go to the interfaces and do it. The newer method is much advanced. It runs on all interfaces as soon as you say that. So when I type show IPv6 EIGRP interfaces, I can see, but I did not go to any of this interface. It has got a instant called we are blessed on all this interface. In router 2, same output, see how it looks, show IPv6 EIGRP interfaces. That's the difference. This is classical method output. This is newer method output. Let me go again. I think I need to go under the address family. That's why it was not showing. Address family, now passive interface. If I say no, what will happen? That doesn't work. Okay, I'll tell you if you do not want to run on an interface how later. So we learned here the two differences. The differences between these two versions. Show IPv6 route EIGRP. You see, I'm seeing the route. I'm able to ping the next router's loopback. But I cannot ping the remote router 3's loopback because I don't have a route. We need to redistribute. So let's see how to redistribute between RIP and EIGRP. First, let me go to EIGRP. This is the older method, you remember. Router. Redistribute. RIP. The name that we gave is you are blessed. And then include connected is mandatory here. And then for the learned networks, you need to say metric. The K values, bandwidth 1000, delay 10, reliability 255, loading 10, MTU 1500. Likewise, I go under RIP. IPv6 RIP, IPv6 router RIP, you are blessed. Redistribute EIGRP 100, include connected, metric, the hop counts. For RIP, you need to say hop count. I'm saying, let's say 5 hops. It need not to be accurate. Now, what I'm expecting is ping from R1 to R3. You see here, show IP route. 170 is redistributed external EIGRP routes. So I can see the route to reach router 3 is Lübeck. Yes, question. I can also show you from R3. I can ping router 1. Question. OSPF you are going to try. Now I'm going to form IBGP between R1 and R3. And I want to use Lübeck to Lübeck peering.
Yeah,
If
sure.
you can do IBGP, it is very easy to do EBGP. Let's do. For that, I need this reachability. I'm going to form peering with this address. So I am already pinging. Router BGP 100. 100 is the autonomous system number I'm going to take. And I'm going to say neighbor 1111:1111. Remote AS is 100. Neighbor 1111:1111. Update source Lübeck 0. Going to router 1. Router BGP 100. See, there is no IPv6 router BGP. Simply like usual, like as usual you do in IPv4, you need to do neighbor. This is router 3's address. Remote AS is 100. Update source Lübeck 0. Now the neighborship will not come. You have only defined the neighbor. What is next is you need to go to the address family IPv6 like you did in newer EIGRP and activate this neighbor like this address family IPv6 unicast neighbor, this one, activate. Likewise, go to router 1, sorry, router 3, address family IPv6 unicast neighbor, activate. That's all. Okay, you will see shortly the neighbor coming up. Show IPv6. See, neighbor has come up. You see that? Show IPv6 BGP. Show IPv6. No, show BGP. IPv6 unicast all or unicast summary. You can see the neighbor is up for last 25 seconds. Note on this command, show BGP IPv6 unicast summary. And you see it is using IPv4 address as the router ID. All other story that you have learned in IPv4 is same with IPv6. For example, I'm going to advertise a network from R3. Interface loopback 11, IPv6 address 11AB colon 11AB colon 11 colon 11AB slash 128. Now I want to advertise this to router 1. So I'll go under router BGP 100 and you should go under the address family to advertise this. Address family IPv6. See, you're going inside the control plane of IPv6. That is the meaning of this address family. Unicast. Network that you want to advertise is this, along with the mask you should specify. That's all. Now I'm expecting this network to be appearing in the routing table of router 1. You see one prefix received already. Show IPv6. Show BGP IPv6 unicast. It says that this network I have learned from this next hop who is local. That's why you have local preference 100. If it is eBGP, you will not see 100 here. And it is valid and based because this next hop is reachable. And when I check show IPv6 route BGP, you can see administrative distance 200, which is IBGP. Because it's a TCP based protocol, your next hop address will not be link local address, it will be global unicast address. Question? Any question? If no question,